really sound like set theory. They really sound like Venn diagram questions, because they are. Now, there is a difference. You could have two types of Venn diagram questions that can pop up in probability. You can have probability Venn diagrams, or you can have just a plain old Venn diagram. That's where you're going to have to calculate the probability from it. Okay? So this one here is a probability Venn diagram. This is the first type. So it's the probability Venn diagram. If you get the feeling like it sounds like you could set it up in a Venn diagram, it's probably because you can. So we're going to look at this one. It says, the probability that Eric will play golf this weekend is 0.5. So Eric playing golf, 0.5. The probability that Eric will play tennis, 0.3. The probability he will do neither is 0.25. Sounds like a Venn diagram to me. The catch is, probability Venn diagrams, I don't actually have to give you a total. Every other Venn diagram, I have to give you a total. Like 100 students did this, or 80 students did this, right? I'd have to give you some sort of total so you can get a total. Probability Venn diagrams, add to 1. Why would they add to 1? What is 1 as a percent? 100%. So every Venn diagram, that's a probability Venn diagram, needs to add to 100%, correct? But if it's in decimal probabilities like this one, they would add to 1, because 1 is the decimal to 100%, it's percentages, right? So we're going to draw ourselves a Venn diagram here. So this is golf, and this is tennis. We have done this over and over and over and over again, where they don't give you the and. Remember? They give you the singles, they give you the outside, but they don't give you the ands. Correct? So what did we always do? We would find out how much was left over when we took the outside off. We'd add up whatever our singles were, and we'd subtract off what was left, because we'd have overlap. Well, let's figure it out. So neither is 0.25. So that goes on the outside. When we add up the singles, we get 0.5 plus 0.3, which equals 0.8. We agree? When we add up the two singles, 0.3 and 0.5. However, how much probability is left in the Venn diagram with that 0.25 on the outside? When we have this 0.25 sitting on the outside, how much is left that we can fill the circles with? 0.75. Because it should add to what? It should add to 100 if we do percentages, or add to 1 if we leave it as decimals, correct? So I know if there's 0.25 on the outside, I literally have 0.75 left for the middle. However, I told you that 0.8 actually did the middle, all these circles. So what am I going to have to do? Find the and. What do we do every single time? Subtract off 0.75. Subtract what's left over, correct? So how much overlap is there? 0.05, and that's going to go here. Now, how do I get golf only? So we have golf has 0.5, but there's already 0.05 in it. So how much is golf only? 0.45. Yeah. And then plays tennis, it's 0.3, but there's already 0.05 in here, so tennis is 0.25. Now the great thing about probability Venn diagrams is I actually have every probability now. I could ask you so many things. I could say, how many people play golf? What's in terms of the probability of playing golf only? 0.45. What's the probability of playing tennis only? 0.25. What's the probability of playing golf and tennis? 0.05. What's the probability of playing golf or tennis? Or is it 0.75? It's the snowman, right? What's the probability of playing only one sport? What's the probability of playing only one sport? What are we going to add? Only one sport. 0.45 plus 0.25. The 0.05 is people playing how many sports? Both, playing two. I said playing one sport only. So I don't add this 0.05 and I point 0.45 plus 0.25. So it's 0.7. 0.70 have the probability of playing one sport only, right? Okay, let's actually answer the questions it says. So here it says the probability that he will do at least one of these activities. At least one activity means one activity or more, correct? So if I said one activity only, it would be 0.7. But this one says at least one activity. So it's the one activity or more. So it could be one activity or both, correct? So that's the snowman. So how much is that? Guys got some serious eyebrows. All right. The probability to the nearest hundredth that he will play tennis and play golf. How much is that? So that's a probability Venn diagram. Probability Venn diagrams add to 1. You just have to remember that. Is this a probability Venn diagram? Does it talk anything about probabilities in it, or does it just sound like a normal old Venn diagram? Normal old Venn diagram. It's just things. In a group of 80 school children, 80 elementary school children, so that's my total. 48 liked cornflakes. 22 liked both cornflakes and oatmeal. 20 children liked neither. Until I read anything after this, that's set theory question, is it not? Right there, we're in set theory. How do we know we bumped out of set theory into probability? Last sentence, what does it say? The probability to the nearest hundredth. So do we treat it just like a Venn diagram? Yep. Make your Venn diagram just like you normally would. Nothing changes. Just when you get your answer, you're going to have to divide it by the total to get the probability. So let's set up our Venn diagram. On Monday is your last lesson of the year. The Thursday before Christmas, though, I am going over rational word problems. Remember, we just kind of let those ride because people found rationals enough to learn all that stuff. So we're going to go over rational word problems before the diploma. Because there's always one. There's always one on the diploma. I feel like, I'm not sure if that's true, but I'm going to say it anyway. There's always one. And we're going to pretend it's a fact. Okay. So, how many are in both? 22, so that goes in the middle. Now, the 48 that like cornflakes, is that cornflakes only? So I have to subtract. What do I get? Then the oatmeal people. There's 20 of them. Nope, that's a lie. How many? We don't know. How many are the 24? Where does that go? Into the neither, so that's in the outside. And what do these have to add up to? 80. So we have 20, 46, 66, 68. So this is? Have I done anything new to this point? Nope, this is set theory. This is why we practiced set theory yesterday, to remember what we did, right? Done nothing new to this point. Then I read the last statement. The probability to the nearest hundredth that a child selected at random from this group liked only oatmeal. How many liked only oatmeal? 12. So we go probability of oatmeal only. Since it's a probability, I need a total, right? So it's going to be 12 out of 80. And it wants it to the nearest hundredth. We have to read our rounding rules. So we go 12 divided by 80. What do we get? We have to start with a 0 because there is no decimal bubble in the first box. So nothing crazy, right? The difference, though, for mutually exclusive or not is what we did yesterday, where we took out a card or we spun a spinner, right? We have to decide that way. Venn diagrams are mutually exclusive only if there's a circle and a circle with no overlap, right? Like a total circle here and a total circle here, and they don't overlap. And the other new thing that we've learned is probability Venns. So those ones are not as noticeable as a Venn diagram, but you have to spot them because they still sound like a Venn diagram. They just have decimals instead. So instead of 12 people liking oatmeal, the probability of people liking oatmeal is 0.26 or something like that. Like it gives it to you as a decimal because it's a probability, not an actual number, right? Now they sound harder, but they're actually easier because you immediately have the answer to every probability question just taking it off your Venn diagram because the whole Venn diagram is full of probabilities. When it's a Venn diagram, you actually have to divide it by the total. Okay? All right, I'm flipping over. Why is this blank on my other one too? I don't know. Oh, it's on the, I remember. I did it on 2 separate ones, remember? Okay, you guys are trying out example 6. And then I want you to try the second example 6. Why there's 2 of them, I'm not quite sure. But I want you to try the 2 questions on this page. The second one is you're going to need a 1x6, 1x6 dice array, just so you know. These ones. So this one here has cycling and skiing. The number of people who cycle is 68. So I can just fill that in, and then 29, I can just fill that. No, I can't. Where do I have to start? With the middle. Number who both cycle and ski, which is 17. I changed to a different one. So 17. Now how many cycle only? 51. Now you're always so used to, this is how it goes with this lesson, set theory in general. You're either so used to subtracting, you subtract every single time you see it. Or you're so used to onlys that you never subtract. But is that a good method to come into the test? No. If it's not only or if it's not cycling but not skiing, you have to subtract, correct? But if it's onlys or it says cycle but not ski, you can fill those in at any point in time. You have to know when you subtract and when you don't. If you're just banking on one method or the other, that's a scary situation going into any type of diploma or this unit test, right? We need to know. And if you're someone who's still like, I don't know when I subtract or not, I just kind of do it all the time. That is something where you need to accept it, pass denial, and then come ask, okay? All right. So here we have ski is 29. How many ski only? How do I get the outside? Add them, subtract from 100, and how many do I get out here? Now this one says, what is the probability the person cycles only? So remember the numbers from the Venn diagram go in the numerator and the total goes in the denominator, correct? So how many cycle only? 51 out of 100, which is 0.51. Now this one, it's an array. What they should say here is I take 2 dice, 2 6-sided dice, and I roll them at the same time. Dominic and Laura are playing a board game. They take 2 6-sided dice. They roll them at the same time. To move a turn, Dominic must roll either doubles or a sum of 7. So I'm thinking, okay, probability of doubles or a sum of 7. So I know when it's or, I'm going to have probability of doubles plus the probability of a sum of 7. Minus the probability of doubles and a sum of 7. Now I'm just writing this down because if this is actually a 0, I can just erase it off and it's actually mutually exclusive, correct? Do you know what I'm saying? If the and is 0, then there is no and. I erase it and I say it's mutually exclusive. The easiest way to tell these, and I know it's time consuming, is to do your array. So we do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I'm going to do an outcome array because I need doubles and sums, which I can do. So I get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. And then I get 2, 1, 2, 2, 2, 3, 2, 4. And I'll show you why I do an array. I know it takes an extra probably 2 minutes, but I don't care because it fixes all my problems that you might have if you don't do the array. Like missing one. All right. So I'm going to take green and circle the probability of doubles. So I go up to the doubles and I circle them all so I can visualize it. There's 1, 2, 3, 4, 5, 6, right? So this equals 6 out of how many? Out of 36. Then we have sum of 7. So I'm going to do sum of 7 in purple, actually. So the ones that would sum to 7 are these. 1, 2, 3, 4, 5, 6. So I'm literally visualizing what's happening here, correct? Now I have to subtract off the purple-green numbers. What's the catch? There are no purple-green numbers, correct? So does this actually exist in my formula? No, so I go back and say there's no purple-green numbers, this is gone. What type of question is this now? Mutually exclusive or not? It's mutually exclusive. Remember, even if you forget which is which, MN, alphabetical, sing the alphabet. MN, mutually exclusive, not mutually exclusive, right? Alphabetically, this formula sheet goes in order. And this one has overlap because I'm subtracting it. You can see that. So if you forget if mutually exclusive or not mutually exclusive has overlap, at least remember alphabetically, M then N, and this one is overlap because I'm subtracting it, right? Your formula sheet gives it away to you. So we know this one's mutually exclusive. And so I get 12 out of 36. Or 1 out of 3. Now I'm handing you this sheet. It has a front and a back side, and you have, it's 11:05, and you have till 11:25, so you have 20 minutes to finish the front and back of this, and we're going through at the beginning of class tomorrow. That means there is no homework, because it's, I said that last class, and they're like, we're not coming on Saturday. Okay, neither am I. Cool. So, front and the back side for you to complete, it's all the topics we've done so far. So there's probability with perms and cons. There's odds in favor and odds against. Odds in favor, remember whatever comes after it comes first. Complement second, adds to total. Odds against, complement first. Other one second, adds to total, right? And then it starts off with these Venn ones, so it makes you feel comfortable because you just did them.